60.77%. That is the number the United States Drought Monitor published on May 26, 2026, for the share of the contiguous lower 48 states currently in some level of drought. More than 3 out of every 5 square miles of the continental United States, from the cracked alkali flats of the Colorado River Basin to the dust-stripped fields of Nebraska and Oklahoma, to the browning pastures stretching across the southern high plains, is moisture deficient right now as this video goes out. And yet, on the same day that number was published, the National Weather Service's Weather Prediction Center in College Park, Maryland, was issuing a forecast discussion flagging a slight risk of excessive rainfall for the middle Mississippi Valley, a slight risk of severe thunderstorms for the Central Plains, and a moderate risk of extreme heat, defined by the Climate Prediction Center as a 40 to 60% probability of dangerous conditions materializing. For a swath of the northern tier stretching from the northern and central plains through the upper Mississippi Valley into the Great Lakes region, targeting the window of June 6th through 7th. At the same moment, the National Hurricane Center in Miami was resuming its routine issuance of tropical weather outlooks for the Atlantic Basin, marking the official start of hurricane season. 6 distinct and simultaneous hazard regimes. 1 country, 1 atmospheric pattern holding all of them in place at once. If you follow atmospheric science, you have probably already subscribed to Sky Space Lab, and if you have, thank you for being here. If you stumbled into this video from somewhere else, this is the channel that documents what the federal monitoring infrastructure is actually seeing in real time, pulls the agency language directly from the public record, and explains what the numbers mean without reaching for drama to do it. If you want to understand how the atmosphere is behaving right now and what the science and the forecast system say is coming, drop a comment with where you are located and what your local conditions look like as you watch this. Share the video if you know someone who needs to understand what kind of weather pattern the country is walking into right now. And then let's get into the mechanism. Part 1. What the pattern is, what it is doing, and what it is holding together. The structure responsible for all of this is what meteorologists call an omega block, and by the last week of May 2026, it had established itself as one of the more persistent and consequential atmospheric configurations of the spring. The name comes from the shape the jet stream forms when the pattern is fully established. A large ridge of high pressure sandwiched between 2 flanking low-pressure systems, producing a curve in the upper-level flow that resembles the Greek letter omega when you look at it on a 500 millibar height map. Under normal springtime conditions, the jet stream carries weather systems from west to east with reasonable consistency, cycling through the country over periods of days. An omega block short-circuits that progression. The ridge in the center acts as a wall. Weather systems on either side of it cannot cross through. They stall, they deepen. And the conditions they are producing, heat, drought, flood, storm, persist in place rather than rotating through. The specific configuration that locked into place during the final week of May 2026 placed the 2 flanking low-pressure systems in the following positions: a western low near Salt Lake City and an eastern low near Ottawa and Quebec, with the central ridge anchored across central Canada between them. This is the basic structural description provided by multiple meteorological outlets drawing from GFS jet stream model output, and it is consistent with the pattern that WPC and Climate Prediction Center forecasters were working from in their official product suite. The National Weather Service, as quoted in public reporting, characterized the pattern this way. Blocking patterns like this are known to cause what forecasters call wacky weather, as high pressure jams the jet stream and displaces storm tracks to the north and south. What does that displacement mean in practice? It means the country is divided into 3 weather regimes simultaneously, and each regime is being held in place by the same block that is holding the others. The center of the country, underneath the ridge, is baking. When the omega block settled into its northern tier position during the last week of May, it shattered nearly 50 temperature records across the mountain west, the Dakotas, the Central Plains, and parts of Texas, with some locations recording temperatures 20 degrees above the climatological average for the calendar date. The Weather Prediction Center's heat risk product climbed to moderate levels for a large portion of the northern plains and upper Midwest during that period, with parts of eastern Montana and western North Dakota approaching major levels, which in the heat risk framework represents conditions where heat-related illness becomes likely for those who have not yet acclimated to warm temperatures. On the western flank of the block, a low-pressure system was generating rain, gusty winds and late-season mountain snow across the Pacific Northwest and Northern Rockies, with the Storm Prediction Center's Norman, Oklahoma office issuing a Level 2 out of 5 risk of severe thunderstorms for a corridor including Bozeman, Montana and Pocatello, Idaho. On the eastern flank, the pattern was producing the coastal cyclone that struck New England on May 30th, a late-spring offshore low that this channel documented in detail in the previous video, a storm with structural characteristics placing it in the upper tier of late-spring New England coastal events in the modern record, including high wind warnings for Cape Cod and Nantucket zones that, according to the NWS Boston Forecast Area's operational climatology, have been issued fewer than 10 times during the month of May over the past 2 decades. At the same time, the New England coast was experiencing coastal wind impacts. The southern branch of the jet stream, curving through Houston and New Orleans and bending toward Miami, was channeling Gulf moisture northward and keeping the south active with daily showers and thunderstorms, producing heavy rainfall from the Gulf Coast through the southeast and into the middle Mississippi Valley. All of this was happening simultaneously. The same block, one atmospheric structure, 5 distinct simultaneous hazard environments. And then, on June 1st, 2026, the Atlantic hurricane season began. The National Hurricane Center's routine tropical weather outlooks resumed on schedule. The significance of that calendar date is not ceremonial, it is operational. It means the federal tropical monitoring infrastructure has formally shifted from standby mode into active season posture. It means the reconnaissance aircraft are on alert. It means the probabilistic track and intensity models are running full operational cycles. It means the country's emergency management system has officially activated the hurricane posture alongside every other posture it is already maintaining for the active pattern on the continent. The question of what the hurricane season is likely to produce and how it intersects with the existing atmospheric state is the question that the second part of this video is going to examine in detail. But before going there, it is worth sitting with the full landscape of what the federal monitoring system was tracking simultaneously in the final days of May and the opening days of June. The Storm Prediction Center's Day 4 to 8 convective outlook, issued in the early morning hours of May 31st, placed a severe threat over the northern plains for both Wednesday and Thursday of the following week, with large hail and severe wind gusts expected as a mid-level trough moved from the northern high plains into the upper Mississippi Valley and toward the Great Lakes. A separate shorter wave feature was forecast to generate isolated storms across the Dakotas on Friday. The Weather Prediction Center's short-range forecast discussion issued on May 31st and valid from midnight Monday, June 1st through midnight Wednesday. June 3rd explicitly flagged a slight risk of excessive rainfall for the middle Mississippi Valley, the northern high plains and the southeast, as well as a slight risk of severe thunderstorms for the central plains and middle Mississippi Valley, driven by a weakening stationary front combining with upper-level energy in a moist and unstable environment. Those are real product designations from the real federal forecast system, issued against the backdrop of the Omega Block, while the eastern seaboard was still recovering from the May 30th coastal cyclone, and the Drought Monitor was publishing its 60.77% coverage figure. Part 2. What the drought says, what the hurricane season says, and why both of those stories are more complicated than their headline numbers suggest. The drought number deserves more than a headline. The United States Drought Monitor is a joint federal product published every Thursday by the National Drought Mitigation Center, the USDA, and NOAA, and it assigns drought severity on a 5-level scale from D0, abnormally dry, through D4, exceptional drought. As of May 26, 2026, 50.77% of the United States and Puerto Rico combined, and 60.77% of the contiguous lower 48 were in some level of D1 through D4 drought or worse. Those numbers represent the worst drought coverage in the United States by that measure in the modern period, a fact that the drought monitoring literature has been tracking since the scale of this year's deficit became clear. The drought is not uniformly distributed, and it is not a single event. It is the convergence of multiple distinct drought episodes that have developed on different timescales, and for partly different reasons, all of which have reached their maximum concurrent extent in the spring of 2026. In the southern plains, 89% of Texas and 99% of Oklahoma were in drought as of March 31st, 2026, according to drought.gov data. In Nebraska, extreme drought, that is D3 on the drought monitor scale, 2 levels below the worst, ballooned from 0% of the state at the start of 2026 to 43% by the end of March. In the West, the snowpack story is the one that has the longest downstream consequences. The Drought.gov snow drought report published on April 9th documented that the Colorado River Basin recorded its warmest March on record at 13.7 degrees Fahrenheit above the long-term normal, and that the combination of that record heat with an already below normal snowpack caused peak snowmelt to arrive 21 to 34 days earlier than the historical norm across western states. That is not a minor calendar shift. A snowpack that melts 4 weeks early is a snowpack whose water is already gone before the hottest and driest months of the year begin. It is gone before the irrigation systems that depend on late-season meltwater have filled their allocations. It is gone before the reservoirs have had the opportunity to capture and hold it. The Drought.gov portal, as of the most recent reporting, noted that significant hydrological drought impacts, meaning low water supply, not just low precipitation, are already occurring across much of the West and will continue through summer. The seasonal drought outlook issued by the Climate Prediction Center and updated on May 31st offered the following. Drought is forecast to persist or worsen across large portions of the interior West, the northern Rockies, and the upper Midwest through at least the end of August 2026. A forecast change was made to note improvement possible across the south-central Great Plains and southern High Plains, where above-normal June precipitation is now expected, driven precisely by the southern branch of the jet stream that the Omega Block is currently channeling. That is the atmospheric irony embedded in the current pattern, the same block that is intensifying drought in the north-central tier by producing the heat dome over that region is simultaneously directing moisture into parts of the southern plains that have been drought-stricken for months, potentially offering the first precipitation relief of the spring to areas that needed it since January. Whether that relief proves durable or whether it is followed by re-intensification of drought later in summer is an open question in the current forecast. The CPC's own seasonal outlook explicitly notes that re-intensification is possible in those regions later in summer, and now, against this backdrop of a drought-stressed continent under an entrenched blocking pattern, the Atlantic hurricane season has officially opened. The National Oceanic and Atmospheric Administration released its seasonal outlook for the 2026 Atlantic hurricane season on May 22, 2026. The numbers are as follows, drawn directly from the agency's public news release. NOAA is forecasting a 55% chance of a below-normal season, a 35% chance of a near-normal season, and a 10% chance of an above-normal season. The agency is predicting 8 to 14 named storms, with 3 to 6 expected to reach hurricane strength and 1 to 3 of those forecast to reach major hurricane intensity at Category 3 or higher, meaning sustained winds of 111 miles per hour or greater. For reference, an average Atlantic hurricane season produces 14 named storms, with 7 hurricanes including 3 major hurricanes. The official 2026 forecast sits at the low end of the climatological envelope in every category. The dominant factor cited by NOAA in explaining the suppressed forecast is the development of El Niño, the climate pattern that occurs when sea surface temperatures in the central and eastern equatorial Pacific warm above their long-term average, altering global atmospheric circulation in ways that have been well documented for decades. During El Niño, wind shear over the Atlantic basin typically increases. Wind shear, which describes the change in wind speed or direction with altitude in the atmosphere, is one of the primary inhibitors of tropical cyclone development. A developing tropical system requires a vertically organized column of rising air. High wind shear tilts that column horizontally, ventilating the warm core that powers the storm and preventing intensification. El Niño conditions tend to increase this shear across the main development region of the Atlantic, which is why El Niño years historically produce fewer and weaker Atlantic hurricanes than neutral or La Niña years. NOAA's administrator, Neil Jacobs, was quoted in the agency's public press materials on the seasonal outlook with the following statement: "Even though we're expecting a below-average season in the Atlantic, it's very important to understand that it only takes one." He cited Category 5 storms making landfall during below-average seasons in the past as context. NOAA's NWS director Ken Graham was also quoted in the same release, noting that El Niño's impact in the Atlantic basin can often suppress hurricane development, but that uncertainty remains in how each season will unfold. Colorado State University's tropical cyclones, radar, atmospheric modeling and software team, which has been the pioneer of early season hurricane forecasts since 1984, released a forecast earlier in the spring calling for 13 named storms, 6 hurricanes and 2 major hurricanes, the fewest number of storms CSU had predicted since 2019. The convergence of NOAA and CSU toward a below-average forecast, both citing El Niño as the dominant suppressing mechanism, provides a consistent picture of what the agency consensus is entering this season. But the federal forecast system's own institutional discipline requires engaging with the part of the story that the headline numbers can obscure. A below-average seasonal forecast describes the statistical expectation across 6 months of activity. It does not describe individual storm tracks. It does not describe coastal vulnerability. It does not predict whether the one storm that does develop reaches landfall, and if so, where. The history of Atlantic hurricane seasons offers numerous cases where below-average seasons produced catastrophic individual events. The current atmospheric state, with the Omega block funneling moisture flows and potentially altering the early season sea surface temperature distribution, introduces additional uncertainty into the seasonal baseline that is worth noting. The WPC's extended forecast discussion, issued on May 31st, noted a deep upper-level low forecast to bring rain to the Pacific Northwest late in the first week of June, with a ridge then shifting eastward to the central Conus early in week 2, amplifying across the northern plains and upper Mississippi Valley. The CPC's probabilistic hazards outlook for week 2 designated a moderate risk, 40 to 60% chance, of extreme heat for the northern and central plains, upper and middle Mississippi Valley, and Great Lakes region for June 6th and 7th. The 500 millibar normalized height anomalies associated with that amplification were forecast in multiple model ensemble means to reach greater than 3 standard deviations above normal over the northern plains and upper Mississippi Valley. 3 standard deviations is a statistical threshold that corresponds to the tail of the distribution, meaning conditions that the historical record categorizes as genuinely extreme rather than merely above average. Part 3. What the pattern reveals about the state of the atmospheric system the country is entering summer with, and what the question is that the federal record is currently holding open. The spring of 2026 has produced in succession a set of atmospheric events whose accumulated weight the scientific literature will be examining for years. This channel has documented each of them in real time as they occurred, and the documentation is accumulating into a picture that is worth assembling explicitly as June begins. The bicoastal heat dome of early May produced extremes from the Pacific Northwest to the East Coast. The global heat wave of mid-May produced records across Western Europe, the United Kingdom, and India. The drought reached its broadest monitored extent in the first half of May. The plain severe weather of mid-May produced multiple slight risk and enhanced risk outbreaks across the central and southern plains, including the May 18th and 19th multi-day pattern. The May 30th coastal cyclone closed out the month with a late spring New England storm in the upper tier of its climatological class. And throughout all of it, the Omega block held, directing energy and organizing hazards with a persistence that the operational climatology treats as outside the typical range. The severe weather record from early in the spring deserves specific attention because it establishes the baseline from which the rest of the season is being understood. The tornado outbreak that occurred from March 10th through 12th, 2026, across the Midwestern and Southern United States produced 105 confirmed tornadoes, according to the Wikipedia Tornado Outbreak Catalogue entry for that event, making it a large and consequential outbreak by any standard of the modern record. The maximum rated tornado in that outbreak was an EF3 that struck Aroma Park and Kankakee in Illinois, and tracked through Lake Village and Roselawn in Indiana, and continued toward the vicinity of DeMotte. The National Weather Service confirmed peak winds of 160 miles per hour in that tornado. 3 fatalities were associated with the outbreak, with 2 deaths in Lake Village, Indiana. 9 people sustained injuries in Kankakee County, Illinois. The same supercell that produced the Kankakee EF3 also dropped hail. A trained storm spotter in Kankakee reported a hailstone measuring 6.616 inches in diameter, the documented figure from the Tornado Outbreak Catalogue entry, which, as of the spring of 2026, was being evaluated as a potential new Illinois state record. For context, 6 inches of hail represents a stone roughly the size of a softball, and the force of an object that size falling at terminal velocity is not a weather abstraction. It is structural damage, vehicle destruction, and in the absence of shelter, a lethal hazard. The same storm produced hail ranging from 2 to 4 inches in diameter along a path stretching from Pontiac, Illinois to the Illinois-Indiana state line, meaning the hail swathe accompanied the tornado track and extended it into populated agricultural and residential terrain. The NWS Chicago Forecast Office documented that through April 19, 2026, the office had recorded 20 confirmed tornadoes in its forecast area, with a typical count for an entire calendar year running between 10 and 20. The office had issued 128 severe thunderstorm and tornado warnings through the same date, which the NWS characterized as a record high through April 19th in its operational history. The total of 14 convective watches issued through that date, 8 severe thunderstorm watches and 6 tornado watches, was also far above the typical 4 to 8 for the January through April window. The NWS noted that the lower Great Lakes corridor, and specifically the swath from eastern Iowa through southern Wisconsin and northern Illinois, had been, and this is the agency's own language from the public event summary, a hotspot for severe weather so far in 2026. The record highs set on March 10th at Springfield at 84 degrees Fahrenheit, at Peoria at 83, and at Lincoln at 82, all of which broke records previously set in 1955, indicate the depth of the surface warmth that was available to drive instability on that outbreak day. Illinois had, as of late April, the highest confirmed tornado count of any state in the country for 2026, with 99 confirmed tornadoes documented through that date, a number the NWS Lincoln office's warning coordination meteorologist, Ed Scheiman, had verified from finalized survey data. What does all of this mean for the country as June begins and the atmosphere prepares for what comes next? The WPC's short-range forecast discussion for the first days of June identified the immediate hazard structure clearly: a weakening stationary front from the southeast-northwestward to the central plains, combined with upper-level energy, generating showers and thunderstorms producing heavy rain over the middle Mississippi Valley and the southeast. A separate weak mid-level disturbance propagating northward across the southern high plains, providing additional forcing for thunderstorm activity across the central and southern plains. A slow-moving surface low, focused to produce scattered to numerous showers and thunderstorms over the northern plains and upper Midwest on Wednesday and Thursday of the first week of June, and then the ridge shift. The WPC's extended discussion, valid through the end of the first week of June, forecast a deep upper-level low, bringing rain to the Pacific Northwest late in the week, followed by the ridge migrating eastward and amplifying across the central CONUS in week 2, driving the extreme heat signal that the CPC then flagged at moderate risk levels for the northern plains through the Great Lakes. That heat, if it verifies, will be arriving atop a landscape that is already drought-stressed. The CPC's probabilistic hazards outlook also introduced a designation of possible rapid onset drought for parts of the upper and middle Mississippi Valley and the Great Lakes region during the same week 2 window. Rapid onset drought, sometimes called flash drought in the research literature, is a phenomenon in which drought conditions develop quickly over a period of weeks rather than months, driven by a combination of heat, low precipitation, and anomalously high evapotranspiration, meaning the atmosphere is pulling moisture out of soils and vegetation faster than precipitation can replace it. The conditions that produce rapid onset drought are precisely the conditions that the June 6th to 7th heat signal and the preceding dry pattern are generating across that corridor. The Atlantic hurricane season, which opened officially on June 1st, is being forecast at below-average activity, and that forecast rests on a genuine physical mechanism, El Niño-driven wind shear, that has a well-documented historical basis. It is not wishful thinking, it is operational climatology applied to the current ENSO state. But the below-average forecast operates over a 6-month period, and 6 months is a long time. NOAA's own press materials, and the statements of both Neil Jacobs and Ken Graham in the official Outlook release, are explicit that one storm is sufficient to make a season damaging regardless of what the seasonal total looks like. The Eastern Pacific hurricane season, by contrast, was forecast by NOAA to be above average this year, with a 70% likelihood, and the agency predicted 15 to 22 named storms in that basin, with 9 to 14 reaching hurricane strength and 5 to 9 reaching major hurricane intensity. An active Eastern Pacific raises the probability of indirect moisture interactions with the southwestern United States and potential increased risk to Hawaii, both of which represent hazard pathways that are distinct from but not entirely separate from the continental, severe weather environment already being tracked. The question the federal record is holding open as this video publishes is not whether severe weather will continue to affect the country in the weeks ahead. The WPC and SPC products already answer that question in the affirmative for multiple regions across the first 2 weeks of June. The question the record is holding open is whether the omega block breakdown, when it comes, will produce the pattern reorganization that some of the longer-range guidance has been hinting at, a shift toward a more amplified ridge over the central conus in week 2 that brings the heat signal north, that potentially reorganizes the severe weather corridor toward the northern plains and upper Midwest and Great Lakes, as that ridge strengthens and the frontal boundaries begin to interact with the unstable air mass building on its southern flank. That is the configuration that historically produces the most dangerous mesoscale convective systems of the late spring and early summer. Large organized storm complexes that can travel hundreds of miles overnight, produce damaging straight-line wind gusts over broad areas, and generate flooding rainfall along their leading edges. It is also the configuration that tends to drive the severe weather belt into the corridors that, as the 2026 spring record has already demonstrated, are capable of producing record-breaking individual events. The country is entering summer with 60.77% of the lower 48 in drought, a below-average hurricane season forecast riding on a genuine but uncertain atmospheric suppression mechanism, a severe weather season that by April had already set records in the upper Midwest for warning frequency and tornado count, an omega block that has been reorganizing and redirecting hazards for weeks and is now beginning to shift toward a heat amplification signal, and a federal forecast system that is, as it always does, watching all of it simultaneously and saying plainly what it can see and honestly what it cannot. The Climate Prediction Center's Spring Outlook issued in March, and its subsequent updates through the Seasonal Drought Outlook, have maintained a consistent thread throughout the spring. Drought conditions are forecast to worsen or develop further across the west and south-central plains through at least June, while precipitation relief is possible in the southern plains. The polar stratospheric vortex disruption that occurred during the winter of 2025 into 2026, and its potential downstream contribution to the high-amplitude blocking events that have characterized the spring, is a question the research literature is actively examining, though the channel's editorial discipline is to flag that the attribution between a winter stratospheric disruption and late spring tropospheric blocking involves a causal chain that the current scientific literature describes as plausible and is studying, not as settled. What is settled is the documented pattern, the omega block held, the hazards diversified, and the country has spent the final weeks of May and the opening of June navigating more concurrent hazard environments than any single population can easily hold in mind at once. That is not alarmism, that is the federal record, read carefully. For everyone watching this from the northern plains or upper Midwest as the week 2 heat signal builds, watch the WPC heat risk product and your local NWS forecast office products. The heat arriving in that window is not typical early June warmth. The 500 millibar anomalies the CPC and WPC are flagging are statistically at the tail of the distribution for the region. For everyone watching from the Mississippi Valley, the stationary front and its associated heavy rainfall risk are still organizing. For everyone watching from the southern Appalachians or the Gulf Coast, the frontal boundaries have been producing flooding rainfall on a near-daily basis for weeks, and the pattern that is generating that moisture flux is not changing in the short term. And for everyone watching from coastal areas that lie within the reach of Atlantic tropical systems, the below-average seasonal forecast is a real piece of information, but it describes 6 months of statistical probability, not the track of any individual storm. The federal system is watching. It is telling you what it sees. The question worth carrying out of this video, the one worth leaving in the comments below, is this. As you look at the weather record your region has accumulated from January through the end of May 2026, what is the single event or condition that stands out to you as the moment you understood that this spring was different from the springs that preceded it? Not dramatic, not the most extreme thing you heard about on the news, the moment when the data, or the sky, or the fields outside your window told you something had shifted. That is what this channel is tracking. Leave it in the comments,